Here is one of the strangest supply and demand gaps in the whole game and film industry. The technical artist is one of the best paid, hardest to fill roles in the building, and almost nobody trains for it directly. There is no technical artist degree. Studios post the role, and then quietly struggle to find a single good candidate for months. That is because a technical artist sits in a weird, valuable space, half artist, half engineer, fluent in both. If you can genuinely bridge those two worlds, you are rare, and studios know it. So in the next few minutes I will show you what a technical artist actually does, what the interview really tests, shaders, the rendering pipeline, optimization, and tools, and, most importantly, the portfolio that gets you hired. Because in this field, the portfolio does more of the work than any answer you give. So what is a technical artist, really? The one-line answer, a technical artist is the bridge between the artists and the engineers. Artists want things to look beautiful. Engineers want things to run fast and stay maintainable. Those two goals fight each other constantly, and the technical artist, the TA, is the person who makes them agree. You make the art run well on real hardware, and you give the artists the tools, shaders, and pipelines that let them work faster and hit that quality bar without waiting on programmers. The role is broad, so it splits into flavors. There is the shader and look development TA, who owns how materials and effects look. The rigging and character TA, who makes characters deform and move correctly. The pipeline and tools TA, who automates the studio's workflows. And the environment and lighting TA, who makes big worlds look good and run within budget. You do not have to be all four. In fact, the fastest way in is to pick one flavor and get genuinely good at it. Now the core of most technical artist interviews, shaders. If you take one thing seriously, take this. Start with the most basic distinction, because they will ask it, the vertex stage versus the fragment stage. The vertex shader runs once per vertex and decides where geometry ends up on screen. The fragment, or pixel, shader runs once per pixel it covers and decides its final color. Vertices move things, fragments color things. Then UV coordinates, the flat two-dimensional map that tells the shader how to wrap a texture around a three-dimensional model. Almost every effect starts by sampling something using U. Versus. Be ready to name common effects and roughly how they work. Fresnel, or rim light, brighter at glancing angles, based on the angle between the surface normal and the camera. Dissolve, using a noise texture as a threshold to clip pixels away. Water and flow maps, scrolling and distorting U. Versus over time to fake motion. Toon or cell shading, quantizing lighting into a few hard bands. Know the difference between a shader and a material. The shader is the program, the material is one configured instance of it, with specific textures and values plugged in. And know PBR basics, albedo for base color, roughness for how sharp reflections are, metallic for metal versus non-metal, and normal maps for faking surface detail without extra geometry. The single best thing you can do, be able to talk through building one effect, end to end. Pick your dissolve or your rim light and explain every step. Next, they want to know you understand the rendering pipeline, what actually happens to turn a mesh into pixels on screen. You do not need to write a renderer. You need the mental model. At a high level it goes, transform, then rasterize, then fragment shading, then post-processing. Transform takes your model's vertices and, through the vertex stage, positions them in the camera's view. Rasterization figures out which screen pixels each triangle covers. Fragment shading colors those pixels, applying lighting and textures. And post-processing runs full-screen effects at the end, bloom, color grading, ambient occlusion. Two ideas signal that you really get it. First, the C.P.U.G.P.U, boundary and draw calls. A draw call is the CPU telling the GPU, render this batch. Each one has overhead, so thousands of tiny draw calls can choke the CPU while the GPU sits idle. Second, forward versus deferred rendering. At a high level, forward lights each object as it is drawn, which is cheap with few lights, deferred draws everything first, then lights the screen once, which scales better with many lights. Knowing when each wins is a senior level answer. They will ask about optimization. Guaranteed. Because, make it run fast, is half the job, and naming the right tools here is what separates a junior from a senior. Draw calls again, you reduce them with batching. Static batching for things that never move, dynamic batching for small moving objects, and GPU instancing for drawing many copies of the same mesh in essentially one call, think a forest of identical trees. Then overdraw, the same pixel being shaded many times because of stacked transparent layers. It is a silent killer on mobile especially. Level of detail, or LODs, swapping in simpler meshes as objects get farther from the camera. Texture atlasing, packing many small textures into one so they share a draw call. Channel packing, stuffing separate grayscale maps, like roughness, metallic, and ambient occlusion, into the red, green, and blue channels of a single texture. MIP maps, pre-shrunk texture versions that stop distant surfaces from shimmering and actually help performance. And poly budgets, knowing roughly how many triangles a character or a scene is allowed. But the line that really lands, you do not guess, you profile. You find the bottleneck first, and you name whether you are CPU bound or GPU bound before you touch anything. Optimizing the wrong side wastes days. Beyond shaders, the other pillar is tools and scripting, because a huge part of the job is building things that make artists faster. Python is the lingua franca. Maya is scriptable in Python, on top of its older MEL language. Blender's whole API is Python, the BPy module. Houdini leans on Python heavily too. Learn Python well and you can automate inside almost any content creation tool the studio uses. What do you actually build? The unglamorous, beloved stuff. Batch importers that bring in 100 assets correctly instead of one at a time. Naming and validation tools that catch broken conventions before they reach the build. Auto LOD generators. One-click exporters that take an artist from their tool into the engine with the right settings, every time. Here is the mindset the interview is checking for: you build tools artists actually use. A clever script nobody adopts is worthless. A slightly ugly button that saves the character team an hour a day is gold. Solve their real, boring, repetitive pain, that is the whole game. Even if rigging is not your chosen flavor, know the basics, and know what a healthy pipeline looks like, because pipeline questions come up for every TA. On rigging, at a high level, a rig is a skeleton of joints, and skinning is the process of binding the mesh to those joints so it deforms when they move, each vertex weighted to one or more bones. You do not need to be a master rigger to explain skinning, skeletons, and why good deformation matters. On pipeline, a good asset pipeline is boring on purpose. Clear naming conventions so tools and humans can find and validate anything. Automated validation so broken assets get caught early, not in a shipping build. And real source control for binary assets, because Git does not handle big binary files well. Studios use Git LFS or, very commonly, perforce to version textures, models, and scenes. The word to reach for is reproducibility. Anyone should be able to pull the project and get the exact same result. A pipeline that only works on one artist's machine is a liability, and interviewers listen for whether you think that way. Now the part that matters more than any interview answer, the portfolio. In this field, the portfolio gets you hired. A strong one gets your foot in the door before you say a single word. Here is what a great technical artist portfolio contains. A few polished shaders, not 20 half-finished ones. And crucially, a breakdown for each: show the effect, then show how it works. The node graph or the code, the UV trick, the steps that build it up. The breakdown is the whole point, it proves you understand it, not just that you found it. One or two tools, presented with the before and after. This export used to take 20 minutes and broke half the time. Here is the one-click version, and the hours it saved the team. Time saved is the language studios respect. Then a reel, a short, edited shader and tool showreel that shows your best work moving, in the first 30 seconds. And clean documentation, because a TA who writes clearly is worth more than one who does not. The rule to remember, depth plus breakdowns beats a pile of half-finished effects. 3 things you can fully explain beat 30 you cannot. Do not skip the behavioral round, because for a bridge role, communication is not soft, it is the actual skill. The whole reason the technical artist job exists is translation, taking what an artist wants and what an engineer needs and making them meet in the middle. So interviewers probe how you work with people. Can you explain a technical constraint to an artist without condescending? Can you push back on an engineer on the artist's behalf? Can you stay patient when someone is blocked and frustrated? The best preparation is a couple of real stories. Have one ready about a tool you shipped that saved a team time, what was painful, what you built, and how their day changed after. Have one about a moment you unblocked an artist who was stuck. And be honest about a trade-off you made between visual quality and performance, and how you decided. You are being hired to reduce friction between two groups that do not always speak the same language. Show that you are the calm, clear person in the middle, and you stand out. So how do you actually break in, especially without a traditional path? There is a clear route, and it is very doable. 1. Pick one flavor. Do not try to be all 4 TA types at once. Choose shaders, or tools, or rigging, and aim there. Depth in 1 beats shallowness in 4. 2. Build 2 or 3 portfolio pieces, with breakdowns. Not a gallery of dabbling. A small number of things you finished, polished, and can fully explain. 3. Learn a real content creation tool plus Python. Blender is free and excellent, Maya if you can get it, Houdini if you want the procedural and effects world. Then Python on top, because that is how you build tools. 4. Contribute to a shader and TechArt community. Share breakdowns, post on the TechArt forums and discords, follow how the good people work. It builds your skills and your name at the same time. And the honest bottom line for this field, a strong reel beats a computer science degree. Nobody hiring a technical artist cares more about your transcript than about what you can visibly do. Show the work. Let us pull it all together, the whole technical artist path in one frame. What it is, the bridge between artists and engineers, in one of 4 flavors, shader, rigging, pipeline, or environment. What the interview tests, shaders, vertex versus fragment, UDOT versus, and PBR, the rendering pipeline from mesh to pixel, optimization, where you profile before you guess, and tools, built in Python, that artists actually adopt. What gets you hired? A portfolio of a few polished pieces, each with a breakdown, 1 or 2 tools with the time they saved, a tight reel, and clean docs. Plus the communication to work between 2 worlds. And how to break in, pick one flavor, build 2 or 3 deep pieces, learn a real tool in Python, and join the community, because a strong reel beats a degree here. I put the full written guide, The Technical Artist Career Path, at the link below. And if you want a shipped game dev portfolio that actually gets you hired, real pieces, real breakdowns, the game dev portfolio pack is linked in the description. $15, completely optional. Subscribe for more honest developer career breakdowns, and I will see you in the next one.